Good afternoon and welcome to this 6th episode on how to build a data platform. My name is MLG and today we're going to be talking about data modeling. This is the series that accompanies the actual physical guide. We've got 100 pages that we've written here at the Oakland Group on how to build a data platform, which goes into far more detail than I can do in this video series. So if you want that guide, then just click the link down below in the description. For now though, let's get into what this is. Oh, you should also do all the normal YouTube rubbish of liking and subscribing and commenting and telling us what we missed and what you'd like to see next and all of that carry on, because quite honestly my marketing department are on that I don't have enough calls to action in the first 2 minutes of the video. So this is a call to action. It's in the first 2 minutes of the video. Like and subscribe. Data modeling. It's good, it's important, and sometimes extremely difficult, because like solution architecture, so if you think back to our episode where we talked about solution architecture, there are whole humans on this earth who walk around and their entire job is solution architecture. Likewise with data modeling. There are whole humans wandering around whose entire job is data modeling. And so if you have a data modeler or a data modeling engineer in your organization, now is the time to go and get them. You know you want a data platform, you've figured out what insights you want from it, you've got a solution architecture together, we've thought about some of the development practices and automation that will go into it. We now need to architect and model the data. If you have a data modeler, go grab them. If you don't, let's cover some of the big themes that you're going to have to think about when you're doing this process. So firstly, we should figure out why we care about this thing called data modeling. Because what data modeling fundamentally is it's documenting, recording, and understanding the different structures and relationships that all of your data has and the different processes that it underpins. From an enterprise level, that's what we're going to do. From a technical level, we have to build things and we have to think about how we are going to do that process. But you're going to start at the top. You're going to go out into the business and gather requirements, because you have in your mind this data platform that you're going to build. Remember our friend here, the data platform box. You are going to build this object, and you remember our business users, I think they were red out here, who are going to get insights from our data platform. These people already do data work. They already make decisions based on evidence, and your hope with your data platform is that you're going to give them more evidence and better insights to be able to support that work. But you need to figure out what data and processes they are already doing, and then how you can support those with a data platform. And that is high-level requirements gathering. So you might go to them and you might say, what is it that you do on a day-to-day basis? And they'll say something like, well, what I do is I take all of the credit card transactions from the last month in our organization, I consolidate them, and then I produce a report. And what you're going to do is then with your platform, try and automate as much of that as possible, or give them a way that they can get that data more easily so that their report is, quicker to generate. This process of requirements gathering, by the way, is not easy. And you might just start small. You might, if you have an extremely complicated organization, you might just take a little bit of it and go, well, this is the bit that we're going to start by supporting with our data platform. You probably don't want to go out to the entirety of a multi-thousand person organization and just requirements gather, because that genuinely, if you do that to the nth degree, might take you years, by which time many of the technologies that I've talked about in this are probably going to be out of date. If it takes you 10 years to do your requirements gathering, then, we might not be talking about Databricks and Fabric in 10 years. We might be talking about something else. Many of the principles will be the same, but what I'm trying to get to here is that requirements gathering is a whole task in and of itself. And again, there are people who specialize in requirements gathering, but if you don't have those, then start small. In my experience as well, this is also the moment when all of the gremlins come out of the infrastructure, because to go back to our example here, you might have somebody who consolidates credit card transactions and you go, brilliant, that's exactly what we expected. So what we're going to do is we are going to support you in this way by having some ingestion process through my favorite, Azure Data Factory, and we've got your general ledger out here, and we're going to pull in that there, we're going to filter for credit card transactions, we're going to store them here, and then surface this through Power BI, let's say. And that is also the moment when they go, oh, actually, oh, sorry, the Western region, oh, they've got a different way of doing this. Actually, Marjorie in the Western region, the only way I know about their credit card transactions, I'm really sorry about this, but Marjorie sends me an Excel spreadsheet once a month. There's Marge. And that gets incorporated into what I do, and I kind of do a pivot table thing on my computer and put them together as best I can, and then I make a little bit of a graph in Excel. This requirements gathering is the moment where all of those spiders and snakes come out of the woodwork, because when you ask people what it is they actually do with the data, they start to tell you all kinds of home truths about the enterprise that you're working in. And you will very quickly figure out the edges of the data model that you're going to need. But you manage that. You do it. You trace down in the little domain that you're building your data platform for, you trace down all of the bags of snakes and all of the weird edge cases and all of the different things that you are going to have to support for those processes. You've figured them out, you've got them, you have decided that you fully understand the process, and you've drawn yourself a nice flow chart that looks maybe like this. You know, you've drawn something that looks a little bit like this, but you've figured it out, right? You've got credit card data that lives here, and you've got the general ledger that lives here, and you know that those two things come together, and that you've got some Power BI here, and then you've got a user. You've drawn out that flow chart and you've documented it nicely. You've done your requirements gathering. The next thing we have to do is what's called conceptual modeling, and we're going to build up to more and more technical steps. And some of these steps are optional. You don't have to do them all, and we'll point out when you don't have to do them. But we're going to work through a 3-stage process. We're going to do conceptual modeling, we're going to do logical modeling, and then we're going to do physical modeling. Some of those are optional, but let's talk through them one at a time. So as I say, we've now got our process. And more importantly, we now have a big list of all of the data that we are going to use to support these processes. So we are now going to pivot from being interested in processes to being interested in data. And so I'm going to get rid of all of this stuff, and we're going to talk about a thing called conceptual modeling. Because in conceptual modeling, what you do is we'll keep Marge, I like Marge. You conceptually break up your data into different enterprise domains. And this is sometimes optional. You don't have to do this if all of your data is to do with finance, then fine, you've got yourself a financial data platform, all right? And the conceptual modeling is very easy. It's the Venn diagram that is a circle that says all of this data is financial data. But let's say you've got something slightly more complicated on your hands. You're doing a multi-departmental data platform, maybe one for an entire organization. One of the things that you should do is you should look at all of the data that you have, and you should break it up into the business units that data belongs to. So you might have finance data, you might have logistics data. Logistics, why did I pick such a long word for that box? But never mind, we've got there now. And you might have manufacturing data. Manufacturing. Such a huge word, even bigger than logistics. I was complaining about that one and I picked manufacturing. Anyway, doesn't matter. This will allow you then to break up your data into its strategic domains. And in doing so, you now have an idea of not only the different sorts of data that you have, but who is responsible for that data. So you can now break this up and put it in different places in your data platform. So you might be thinking about, how do I design the storage in my data platform? And how am I going to break up all of the data into its different partitions or domains to be efficiently allocated in that storage? Because eventually you're going to have to find this stuff inside your storage. So you are going to have some storage, which, remember from our earlier videos, is probably cloud-based object storage. And somehow, at some point, some developer is going to come along and say, I want to build a KPI for all our manufacturing data. I've got some important work that I need to do for the director of manufacturing, and they need a KPI. How do you find your data inside your storage container if it's not broken up into these conceptual models? That's a rhetorical question. It's very difficult to, okay? I'm not asking you, I'm telling you, that unless you do this process, your developers later, or anyone who interacts with your data, is going to have a hell of a time figuring out what goes where. So you are going to want to have this conceptual model where you've broken things down into enterprise location, because you can then allocate these intelligently inside your storage into different places and different containers or different storage accounts or different S3 buckets or whatever it happens to be. And that will allow people later on to find that data much more easily. This also gives you a chain of command. If something goes wrong in the logistics data, you don't screw up lots of different parts of your storage and data platform. You screw up just one little bit of your data platform. And you also know who you ring up to shout at to tell them that the logistics data is wrong, because there is some avenue of responsibility here. By having a conceptual model that breaks your data down into all the different components and allocates responsibility on an enterprise level, you can make these decisions and these processes much easier. So we've got a conceptual model. We've broken down, say, the finance data, and in the finance data, we know that we've got customer data, and we know that we've got transaction data. And then in the logistics one, we've got, like, I don't know, parcel numbers and conveyor belt serial numbers. And in manufacturing, you've got stamps and KPIs and however quickly you're making things. But let's concentrate on the financial data so that we can think about a logical model. Because the logical model is the next step of our data modeling. And we'll get rid of all of the other departments so that we can concentrate on finance. Because when we come to do a logical model, what we are interested in is the relationships between all of the data. So inside this, we are going to say, right, so we've got finance and we've got customers and transactions. And you break that down and you go, well, customers, they have names, they have addresses, and then transactions, they have customers and they have amounts. And in a logical model, what you do is you start to say, well, these customers here in these transactions, those are the same as these customers in our customer table. And so we have a relationship between our transaction table and our customer table. And we also start to specify what it is that makes the data unique. So do these customers have ID numbers that somehow make them unique? And you start to create this logical model. And this is the point where you might see people start to create these big spider web type diagrams that identify all of the different relationships between the items in your data. So you might start to talk about like one-to-many relationships or one-to-one transactions, or points where you have joins between your tables. That is a logical model. And by building this up, you can start to think about how your data is going to be stored. And if so a really good example of this, right, is that if you know that transactions basically always get joined to your customer table, then well, later on, we might just do that. We might just make sure that transactions just always have the customers brought along with them. This process allows us to do the final thing, which is called physical modeling. So we've done conceptual modeling, where we allocate data to areas of the business. We've done logical modeling, where we start to look at the relationships between the data. Now we do physical modeling, which tells you how technically does the data exist in state. What is it? And that will inform how we go ahead and transact it later on. So you might look at this and you go, well, actually, there's a join between customer and customer here, and this customer is a string. And that technical procedure is what what physical modeling is actually all about. It's about figuring out on a low technical level what actually is this data. So you might say, well, that's a string, that's an integer, that amount is a float, and you can figure out what level of precision you might actually have. So that might actually be a float to like 2 dp because it's money. And so that's important. This physical modeling tells you how is the data out there actually represented on a technical level, because that's going to inform the SQL or the code that we use to pull that data into our data platform. And actually, if you make a really good physical model, there are programs and software out there that let you make a physical model in a GUI and draw it out. And then they just make the SQL for you. You tell it what flavor of SQL you're going to use to pull all this stuff in or modify this stuff in place, and then it will make it for you. Now, some of those can be skipped, right? Like if you are just making a very small data platform that only has a few tables in it, you might need to not bother with conceptual modeling because you know that you just have customers and transactions and they all belong to finance. And so, well, conceptually, they're all just in one place. That's fine. We don't have to worry about that. And that also makes our logical model very easy. I could do that on the back of an envelope. It's right here. Look. And that means that the physical model then comes out of that and I can just go ahead and ingest that data into my data platform. Something else you have to consider when you're doing data modeling is that now you've got the data into your data platform, what should we do with it? Now I'm going to talk about the two processes that go on inside a data platform and two of the ways that we model and architect data inside a data platform in order to be able to make this as useful for your end business users as possible. Now let's put that business user back because we're going to draw out once again our data platform, our lovely box of a data platform, and we're going to pretend that we're bringing in these two pieces of data. So we've got customers and transactions, and they are being brought into our data platform. Should we go blue this time for a data platform? Let's do that. We've got a data platform just here, and we're bringing in some financial data. And we've done all of our data modeling. So out here, we've had a chat with Marge and we've brought things in and we understand what we are bringing in. We've got some ingestion engine, Azure Data Factory, or maybe we wrote our own, doesn't matter. How do we store that data in the middle in such a way that our end business user has as good a time as possible? Well, one of the classic ways to do this is to use a thing called a medallion architecture. And a medallion architecture basically has three zones. So I'm going to draw this. Imagine this is all the storage that's inside our data platform. We have three zones. We have a bronze, a silver, and a gold zone inside our data platform. And there is code that we have written that ingests this financial data into the bronze layer and then promotes it to the silver layer and then promotes it to the gold layer. And when it does so, it makes different transformations at each step. Now, I'm going to confuse things a little here and muddy the water slightly. And I'm sorry about that because we've actually found here at the Oakland Group that these colors have been, if you'll forgive, bastardized by the industry slightly. And they don't mean standard things across the industry. So we would prefer to think of these as more descriptive category names. So we have raw, conformed, and curated. Now, structuring data in a data platform in the raw layer, the conform layer, and the curated layer is hugely up for debate, and there are lots of different ways to design this. I'm only going to talk about a couple. If you are interested in this, we go into more detail not only in the data platform guide that is available to you down in the description, but also there are just whole books written on this topic. Things like Agile Data Warehouse Design is a giant in the field. But I'm only really showing you this, not because you should really read this, except perhaps as a cure for insomnia, but just to show you how deep this field actually goes. Here's our idea. So we're going to ingest our financial data into our raw layer. And in our raw layer, we keep it exactly as it is in the wild because we want to be able to reproduce problems that are in the wild. So we just take whatever is out here and we move it into our raw layer and leave it alone. So anytime there's an update out here, we're going to change the raw layer, but the raw layer is an exact representation of what's actually happening on the outside world. The conformed layer then is an upgraded version of raw. When we transform the data from raw to conformed, which we might do, say, like once a day or once an hour, or we could even stream it if it's business critical that we have these things exactly on time. But when we promote to the conformed layer, what we're doing is we're deduplicating the data. We deduplicate it, we take out some of the nonsense artifacts, we might remove all the null rows, say, in the data, and we might start to apply some light enterprise rules. So we might start to, though this is again up for debate, join some tables together or normalize tables and break them apart if that's what's needed, but it's only light touch at this point. We're basically doing data quality checks and quality of life things from raw to conformed. We don't really want to store the same thing twice. Like if we have two customer tables out here and we know that one of them is for one region and one is for another, and there are some customers that appear in both, but fundamentally it doesn't matter because both of those tables have exactly the same columns and exactly the same data in them, and it doesn't matter what region they come from. That's the moment here where we might do some kind of deduplication to just produce one customer table that has all of the customers in it deduplicated. You might do that in the conformed layer. When we upgrade to the curated layer, however, this is the layer that our business users are going to interact with, or at least it's the layer that the software the business users look at is going to interact with. So we have to make some bigger decisions in the curated layer. Because when we're in the curated layer, and we're going to expand out again, so you remember how we had like the conceptual model, we got rid of that, we now have our platform, we're going to get rid of this and we're just going to look at the inside of the curated layer. When we are in the curated layer, we are designing data structures for actual humans to interact with. And so we need to do this in the most intelligent way possible so that our business users don't become so hacked off with the way that we've got the data inside that they stop using the platform and go back to their old Excel tools and bringing up Marge and so on. I'm sorry, Marge, I don't mean to malign you like that, but that's how it would go. So we have a big curated layer like this, and we are taking our conformed data from over here and we are placing it into this layer, this storage container, this area, in as intelligent a way as possible that our business users can get insights off of it real quick. Now, a classic way to do this is what they call a star schema, or a Kimball data warehouse design, which was a term coined by some chap called Kimball sometime in the 80s or the 90s, but it effectively organizes your data into a star or a hub and spoke. So you might say that we have a customer, and that customer has certain facts associated with them. They have a name, they have an address, they have other things going on. Then we have extra dimensions that customers can have. So they might have transactions associated with them. Transactions associated with that customer. They might have deliveries associated with them. And each of these things has in itself facts associated with it. So this dimension of transactions has, an amount fact and so on from there. The deliveries likewise. They could have other things that go on. They might have, we're going to make things up here, like family members. Both family members themselves are probably customers, and that's a bad example, but you get the idea. You have this one central logical entity, the customer, and that has facts and dimensions associated with it. This is great for, like, Power BI is expecting you to have a data model like this. This is how Power BI works. If you've ever looked at somebody who develops for Power BI and asks them, and you go ahead and ask them, what does your data model look like? They'll flip to a different screen that looks like this. And so if you have a very heavy Power BI using organization, this might be a great idea. However, as with anything, other opinions are available. So you might not want to do this at all. You might do a thing called one big table, which I really like just because the name's quite funny. But when you have one big table, you look at your model in your curated layer slightly differently. So you might, instead of having this, you literally have, as the name suggests, one big table. And that one big table contains and represents all of your data. And to do this, you have to figure out which component of your data is the most important. And so we might have business users and they're really interested in transactions. So you just make yourself a big sod-off table that has every possible transaction in it that you have ever had. And every single transaction has a ID number, and it has an amount, and it has a customer, and that customer has, you might have cust family, and you might have a delivery here, and then you might have extra things like delivery number and delivery location and so on and so on and so on. And you just take all of that data that we had in that hub and spoke model, that star schema, and you shove it into one big table. This is good for two reasons. It's good because it's nice and simple and everyone can understand this. You don't have to look at this very long until you can figure out, oh yeah, I see what's going on here. But also, this is like machine learning ready. Machine learning is expecting you to have data laid out like this. And if you talk to a machine learning engineer or a data scientist, they'll start to talk to you about things like matrices and test and train data sets and pulling tables apart so that they can model on part of it and then test on another. This is machine learning ready to go. If you were to do machine learning in a star schema, you'd have to put all the data back together to create this object, and then you can do ML. So if you're in a very ML heavy organization, you might consider one big table. A final honorable mention with data modeling, which is not anything particularly to do with either star schemas or one big table or any of the other competing data architectures that exist out there, is master data management. If you have a well-modeled, well-organized data structure, you can start to do MDM, master data management, which is where you take all of your data and you produce one source of truth. So customers are a great example of this. If you do master data management on your customers, you might just have an objective, truthful list of all of your customers that has no duplicates in it, and you are assured that that data is accurate. In order to do that, you're going to have to assemble all of your data together in one big data model and figure out as best you can where you have duplicate customers and start to assign them ID numbers or keys or something that uniquely identifies those customers. So you might say, you know, if you were to take my name, MLG is the same as ML space G or M.L.G. and you assign me some ID number, you know, like 0001 or something like that, that says, well, all of these customers are actually the same person with, you know, poor taste in glasses and a dodgy beard. That's that guy over there. He is unique. That's the key you give to him. MDM is quite expensive, all right? It's worth saying that if you pipe all of your data into off-the-shelf master data management tools, it gets real expensive real quick because that's really hard to do in a very complicated procedure. But it can be done if you have a very good data model. You might also choose to roll some of your own master data management. So you might have procedures inside your data platform as you upgrade. You remember our data model here that went from raw to curated to conformed? Sorry, wrong way around, raw, conformed, curated. You might do light master data management at each step. So when you upgrade from raw to the next level, you go ahead and you remove duplicates, and that does some of your MDM for you. When you upgrade to the final curated level, you might add ID numbers to your customers or whatever it happens to be in that. You can have some success, and indeed, we as a consultancy have had quite a lot of success writing our own master data management scripts. Good gravy. Well, that's data modeling. And if you followed along by this point, you've now got a whole bunch of the decisions that you need to make to build yourself a good data platform. We've looked at the value in it, we've looked at the solution architecture, we've made some technical decisions, and now we should have some idea of how you can go out into the wild and talk to people like Marge to do data modeling to support this process and fundamentally deliver value for your business customers. If you want to read ahead, or if you want some slightly more detail on the things that we talked about today, then this is available to you, this 100-page guide to download in the link that I'm going to go ahead and put in the description. I have been MLG. You should like, you should comment, you should subscribe, you should ask for more content. This has been data modeling. Next week, we're going to talk about the internals. So those arrows that we were drawing from one data layer to the next, we're going to talk about the internals of your data platform because we're going to talk data pipelines.